بسم الله الرحمن الرحيم. الحمد لله رب العالمين، الصلاة والسلام على نبينا محمد وعلى آله وصحبه أجمعين. Welcome all for lecture 8, data structure course. This lecture, inshallah, will start to EQ. Our objectives at this lecture, so by the end of this topic, you should be able to analyze and define memory requirements for Q data structure. Also will apply programming skills to implement the Q data structure, will develop appropriate algorithm to perform different operations on Q data structure. Also, for this purpose, we will discuss some subjects such as what is a queue and what are the major types of queues, main queues operation, and we'll learn how to implement a queue using array and linked list stores. So also we'll discover some queue applications. We have two types of queues. This is for queue and dequeue, normal queue, and we'll target, inshallah, in part number 2 for priority queue. In this part, we'll start for a queue. What is a queue? A queue is a data structure, but with properties for first in, first out. A queue is as a flow in pipelines. A queue is a line. So what is the line meaning? Meaning is that first person inside this line will be first served. A queue abstract data types, the store arbitrary objects, also when insert and delete or manage stores based on this schema for first in, first out. How to insert, how to remove for a queue. Actually, for the last subject for last data structure already taken for stack. So what is the difference between a stack and a queue? A stack is follow schema for first in, last out, but for a queue, first in, first out. So this is for insert, and a queue will insert at rear, and for remove, and the queue will remove from front. So take care for where insert, where remove. So where insert at rear, remove from front. So we have two main queue operations for to enqueue or dequeue. Enqueue means to insert new elements to queue, but dequeue meaning is that to remove elements from the queue. For enqueue at rear. For dequeue from front. Let us to see for set of operations for a queue. Get front, get rear, get size, is empty, is full. So these functions and normal for to read front element in the queue, to read rear element in queue, to read or to inquire about size of the queue, how many elements in queue. Also to check if the queue is empty or is full. I think is very normal functions or common for all data structures. So what is the boundary cases? Attempting the execution of dequeue or first on an empty queue, return null. So take care for boundaries problem. The main queue operations we will talk about enqueue and dequeue. This is the main function or main queue operations. Enqueue meaning is that to insert the element in queue. This is queue before adding the element. So this is, suppose we have 20 and 78, two elements in the queue. The first one is the front, the second one is at rear. So if we try to insert where the second or is the next position will insert, we actually will insert at a rear. So rear will move to our element will add it. So enqueue operation will add 34, and this rear or index will move to point to the new element. For enqueue, actually will move rear. For dequeue, actually will move front. So here we have now 20, 78, 34. If we try to dequeue, will dequeue from front, so will dequeue 20. So 20 will removed here. And back again, the front will point to 78 and the rear is still untouched because this is DQ. So DQ handle front, but NQ handle rear. Take care for which will axis or deal with the NQ and DQ. This example for, suppose we have Q and we try to NQ5, NQ3, and DQ, NQ7, DQ get front. What is the result? What is the output here? And what is the state of a Q for each operation? This is for NQ5, meaning is that NQ, so no output, but the Q will add it by 5. NQ3, meaning is that no output, but the Q will add a new element 3 at rear. So this is well added at the rear. So take care for 5 at the front now and 3 at the rear. So if we try to DQ, meaning is that we'll remove 5. So remove 5, remove from front. So 5 is the output and the Q now include 3, only one element. And so on for each one. Here for DQ, if you try to DQ, well, this is underflow, meaning is that you try to DQ, which is empty, so we'll return null. Is empty, true, and so on for you can NQ to fill the Q again, start from 9 and then 7. So get size now 2 elements, and so on for DQ by to remove from front. I think this example can explain how to insert, how to remove, and how to inquire for front and inquire about is empty or not. A Q implementation, we have 2 methods to implement a Q. The first one for array, and second one for linked list. Array, actually, we have 2 subjects, we have 2 types of array, linear array or circular array. Why using circular array? This is a problem we will learn in next slide to overcome some problem in array, linear array. Array meaning that we'll try to sequence at based on 0 based, and linked list, dynamic linked list is not fixed, and try for. We have single linked list we can use or use circular linked list. I think everyone now aware about array and linked list all types. Let us to start for array implementation. The front of the Q is indicated by index, a front index. So take care for if you try to NQ or DQ, we have 2 indices. The first one for our 2 variables, first one for front and second one for rear. The front used for DQ and rear used for NQ. If we try to here insert a new element, we'll insert at rear. So we'll use rear index and then increment the rear index with NQ. And if we try to remove element, we remove from front, so we'll increment a front index by increment 1, and so on. This is will move with DQ, and the rear will move with NQ, and so on for each one. What is the problem here? This is the implementation for NQ, implementation for array. For Q are using array, so we just will declare integer array Q, and we need to declare a front, rear, and size and count. Why using all these? Because the front to handle, to manage for remove DQ, and the rear to manage NQ. The size, this is the maximum size because this is array, right? But we have count, meaning that's the actual element. So this is the actual element, but size is the maximum size we'll add it here. You can declare and create a new object of the Q, and then NQ, different elements, and you can display, and you can DQ to remove and display again to test your Q. This is implementation of Java using set of methods. What is the algorithms? Here for the Q algorithms, the first one is full to check if a Q is full or not. For array, using array implementation, meaning that we have maximum size and we have actual count or actual element in the Q. So if count equals size, meaning that the Q is full. Is empty, meaning is that our count equal 0. So to enqueue, meaning is that to check the first if your queue is full. So display queue is overflow to overcome overflow. Otherwise, so set queue of rear index equal value. So our value will add it at current rear. Okay, so current rear, meaning that's empty cell that will receive the new element for enqueue. And next to that, we have to increment the rear index to become rear index plus 1. And then increment the count equal count plus 1. So index that will point to the next element will add it to the queue. But count will meaning that the number will count the number of actual elements in queue. To the queue, we have to check if it's empty and then to overcome underflow. Otherwise, to remove element, we have to remove from front index, and then this is to keep it in temporary variable, and then increment a front index by 1 and decrement count by 1, then return the temp. Take care for the queue will return variable from the same type of queue as integer. So suppose we have this array and we'll added this element for this element from 0 to 49. So we have 50 elements queue, and then we can add one by one. Add a rear and the front at 0. So we can add at 0 and then move to increment by 1. So add 1 and increment by 1. So we have 3 elements in queue here. For enqueue also, one element will add it or enqueue at 3. Now rear at 4, incremented by 1. But this queue is still, there is no DQ calling. But the last one is to after DQ, so the first element will remove at the front. And the front will move to the next point to the next element. So now, if we try to add more elements, we'll insert at the rear by enqueue until reach to 49. If it's complete full, so meaning is that we cannot add more than this because in size and count equal for 49. This is meaning that the queue is full. Even we have empty cells, yes, because this is the problem in array. So how to overcome this problem? So we'll overcome in the next slide. Suppose we have 50 calls here, so empty, all cells in queue already filled, and the queue is full. So suppose we have 4 calls for DQ. Now we have 4 elements available to enqueue, but it's not, we cannot enqueue. Why? Because all elements at the front, so we cannot add. The queue is not full, but it is wrong to add at position index. This is a problem for array, linear array. How to overcome this problem? We have to method to overcome. The first one is very expensive. For each DQ, we can shift all elements to 0, and then keep all elements empty at the end, at the rear. So that's meaning it will, for each DQ, meaning that will shift all elements, but this very expensive. This is the algorithm for shifting for DQ. Using a shift will repeat from 0 to rear index -2, and then for each one we can shift all elements. So all elements available will keeping at the rear. So if we try to enqueue, this is well available. But this solution is very expensive and we cannot use. The second solution, we can use circular array. Circular array meaning that will convert the linear array to circular by using modulus function with size of this array. So if we try to using a modulus for a size, this is well back again to start from index 0. Suppose the rear at 15, so if we use the next element in rear, so we can use modulus with 15, this will give us 0. So 0 element will enqueue. Rear will move here to rear to 0, and then we'll try to add enqueue, and so on. Take care for when the rear end is full and the front part of the rear has empty slots, a new insertion should go into the front. This is the NQ using circular array. This is circular array for NQ. What is the difference? The difference only for a rear index. A rear index +1 will use with modulus size. So the next rear, meaning that will use rear index +1 with modulus size. This is will give us the new element. Here also for DQ to remove also will use the same with the front for remove and to back again to 0 to remove from the start. And then this is will use +1 modulus size. This is the only difference between using a circular array and the linear array. So now Q implementation array, this is the Java code, the same. You can convert the same algorithm for NQ here. And this is this is a normal without circular. And the next, I think this is circular. This is the application, and this is the circular here. For using a front +1, modulus with size, also for DQ. Again, also for NQ, this is will be with rear modulus with size. So now this is NQ with modulus with size for rear. For DQ modulus with size, this is for DQ. This is for implementation using circular array. Otherwise, all implementations the same in linear array. So no difference, only even that statement only is the difference between a linear array and circular array for DQ and NQ. All implementations the same. Now, we'll move to Q implementation using a linked list. Everybody knows the difference between array and linked list. Array is fixed size and will face a problem for available slots, but we cannot add, so you overcome about circular array. But here in linked list, we have single linked list and circular linked list. A single linked list meaning that the last one or at the rear, this is well terminated by null. But circular meaning that the last one rear point to front element. How to implement using this is a linked list, no need to specify maximum size of the queue. So now we can use a linear linked list, for example, implementing using a front and a rear. For the head will use as a front and the tail will use as a rear. So what is the method in linked list we can use to NQ and what is the method we can use to DQ? So the method we'll use for NQ is add tail. Add tail meaning that we'll add a new element at rear. So we'll add the new element at the end of a linked list, this NQ method. So we'll handle the tail for rear, but for DQ we'll handle head. So DQ meaning is that remove. So we need to remove first element from the first linked list. So this is everybody know actual, conceptual, and physical linked list. Don't need to stop here. That just for front and rear here. For front is the head, rear is the tail. So for NQ meaning is that the rear will move to the next added. For DQ meaning is that the front will move to point to the next element. So this is the implementation using a linked list. So there is no size, just declare object from a Q linked list, and then we can use. So what is the NQ and DQ implementation? DQ and Q take care. NQ for add node, add tail. But for DQ, remove element from first. So NQ is the same implementation of add tail. So we can create a new object from node and then check if it's empty, meaning that the first element added to the linked list. So we can set front equal a new node and the rear equal new node in the same time. This is the first node added. Otherwise, set rear.next, the last node, point to new node, and then rear equal a new node, and count +1. This is for add tail in Q. So rear equivalent to tail, and NQ equivalent to add tail for linear linked list. The DQ for to remove element from first, just move front to front next, and then decrement count by 1. Here, if count equals 0, then rear equal null. Don't forget to count equal plus count 1. This is for NQ, and for DQ, just count equal count minus 1. This is for linear, but here for circular, the matter is difference. For just we try to add rear dot next. Here rear dot next equal front. This statement will discriminate between the linear and circular linked list. So NQ meaning is that add node at the tail, we have to prepare rear or a tail dot next to point to the front. Right. This is for NQ. But for DQ, we need another method. For a rear dot next must be equal front. Also, a front equal a front next. This is the part to remove from first, but the statement added here for a rear dot next equal front. Here, rear dot next equal front. This is, I think, by mistake. A rear dot next equal top. So let's move to. So again, this is for NQ circular linked list. Rear dot next equal front, meaning is that rear dot next equal front. But here for rear dot next equal front also for DQ to prepare the new node added here should be point. This is for DQ, meaning that the rear dot next should point to the new front, because DQ meaning is that remove first. Remove first will remove the first node. Now we have a new first node, so we have to change rear dot next to point the new front. Here, this is a statement also for circular, but here for NQ, meaning that we have to change front, because this circular, not double circular. This is not double linked list, not circular double linked list, but circular single linked list, circular linked list, not double. It's not double, so one way from tail to front. So here rear dot next equal a front also. A rear dot next here, rear after added the new rear. Here, this is the new node dot next. We can use here a new node dot next equal a front. It's the same. This is for 2 point circular linked list. We can use a double-ended queue or can add and delete from both front and rear. So we have two options to add, to insert or to remove from front or from rear. So this is NQ front, NQ rear. Also, we have DQ front and DQ rear. This is using actual with double-ended queue, double-ended queue. So if we have double-ended queue, we can NQ and DQ from both front and rear. This is the conceptual. Also for physical, we can use this rear and front in the same. This is for NQ rear. NQ rear meaning is that NQ rear will add, this is the normal. This is the normal way. But take care, we have a new variable for this linked list. For previous should be added, and you know that the previous will equal to rear. This is the only difference. For this is take care for we have double linked list, so we have 2 pointers for next and previous. And we have to check for new node dot previous, we have to update it by rear. Also rear dot next equal new node here for that. This is for NQ also at front. This is the new method. This is the new method for because actually will NQ at rear. This is the normal, but this is the abnormal. This is a new method for NQ at front. So this will add a new node at the front. So the same add node at first. So this add at first, and then we need to update also for this is using a linked double-ended queue linked list. So this is new node dot next equal front and so on for each one. Also, this is double-ended linked list. So what is the equivalent for this method? This is for add new method add first. So of linked list. But take care for we have previous and the next pointers. DQ at front, this is the normal queue for remove first. So remove first, just front equal front dot next, and take care for front dot previous equal null. So this is not circular double linked list, but this is double linked list without circular. this double-ended queue. Double-ended queue, meaning that is not circular double linked list. This is for DQ at rear. This is not normal because DQ actual at front. So we can use a new method for DQ at rear. Just will use this to remove tail. Remove tail. So how to remove tail? We can use previous here, a rear equal rear dot previous. This will remove tail element. And take care for new rear dot next should be equal null. Okay, so this is double-ended queue. This example for using a linked list for double-ended queue. This is for NQ front 3. So NQ front meaning that at the front 5 and then at front 3. So this is added at front. NQ rear meaning that will add at the rear at 7. Get first meaning that will return 3. DQ front meaning that remove from front equals 3. Get last will return 7. DQ rear meaning that will remove from the rear will return 7, and so on for each one. So thank you for using a queue, using a real linked list. This is the actual for the part 1, and inshallah next session for part 2. Thank you.